In the previous video, I showed you how to calculate the MaCaulay duration using the formula. In this video, I will show you another method. This method is more efficient. So we understand that the MaCaulay duration is defined as negative of differentiation of the price with respect to 1 plus y. Then divided by the price of the bond and multiplied by 1 plus y. Now this definition will lead to the closed form solution, which is a formula. However, we can actually calculate it this way by having this differentiation of the price with respect to 1 plus y directly. To do that, I need to make an identical copy of these calculations. But before I can do that, I need to remove all the anchoring of these calculations. So when I copy, the references of these formulas will be changed accordingly. Now, to do that, I will have to do replace, and Control H will give me that. So I have to replace any anchoring, which is $sign, by blank. So I do replace all. So there are replacements. Now I have removed all the anchoring. I can do the copy and paste. So copy, paste. The differentiation is a result of price change by changing the yield very slightly. As a result, we should just add a little tiny amount to this newly copied yield. So equal the old yield plus a tiny little amount, let's say arbitrarily 0.00001. Now, as you can see, the price of the bond is now lower, as it should, and that's because when the yield is higher, discounting is more severe. As a result, the price of the bond is lower, as we have discussed before. Now we can proceed to calculate the differentiation. The differentiation is nothing more than the change in price. So we take the higher price minus the lower price, divided by change in yield, which is the higher yield minus the lower yield. Now we should know that change in 1 plus y is the same as simply change in y. Simply the constant 1 doesn't affect anything. As a result, we have this differentiation. Now the second step is to adjust by the price of the bond and 1 plus y. So we take the result that we just calculated, divide by the price of the bond, which is 123.026, and then multiply by 1 plus yield. Now we have a duration of 8.92 years. As you can see, that this is very similar to the one that we calculated before using the closed form solution. So if I change this little quantity to even smaller, you can see that the second method is approaching the closed form solution. So this is, we call the numerical method. And this method will be a little more efficient as we talk about convexity later. There are many definitions for convexity. But no matter how they differ, they all measure the nonlinearity or the curvature of the price-yield relationship, as we have discussed. For the sake of demonstration, we just use a very simple definition where the convexity is equal to half of the change in duration divided by change in yield. Now, in order to do that, we need two duration results. We have already had one duration result using a little bit higher yield. Now we will use a little bit lower yield to produce another duration result. Hence, I have to make a copy of the calculations down here. And then I have to subtract the same tiny little quantity from the yield. So I'm going to minus 0.123456 zeros and 1. Now, when I change the yield, I have a new price, which is a little bit higher. As a result, I can calculate my new duration, which is equal to the higher price minus the lower price divided by changing of the yield, which is the higher yield, minus the lower yield. And then the second step is that I take this calculated result divided by the price of the bond, which is the market price, and then times 1 plus the yield, the original yield. Now I have a new duration result, which is slightly higher than the old duration result, but they are very close. So the convexity, as I just defined, will be half of the change in duration, which is the higher duration minus the lower duration, divided by the change in yield, which I can either use these two yields or I can use these two yields. So let's just take this higher yield minus this lower yield. So my convexity is 46.9083. Note that convexity has no unit, hence itself has no meaning. You have to compare to another convexity number to know whether it is relatively higher or relatively low.